Hello, welcome back. Welcome back to the Huawei Routing and Switching Elite Training. Today topic we're going to cover the MPLS VPN. I'm Nick Yap from InfoSite Sandian Berhad. So today we will go through the MPLS VPN. So let's have a look. Let's get started for the forward. So first we need to know that what's a MPLS VPN. It's a layer 3 virtual private network technology, and they're using advertise the VPN route using a BGP and forward the VPN packet using the MPLS on the ISP backbone. And MPLS VPN that use in the IP network as a backbone for VPN become an important approach for the IP network carrier to provide the value-added service. So before whoever go for the MPLS VPN, you should get some basic idea what you mean by the MPLS. MPLS is stand for the multi-protocol label switching. Instead of using IP packet, we're going to use the labels. So under this objective, we will not go to basic on the MPLS. We go straight to the understanding MPLS VPN principle, master the MPLS VPN configuration command, and improve the MPLS VPN troubleshooting capabilities, and strengthen the MPLS VPN exam skill. So let's have a look. For the first, from the content, same, we will go through the principle, configuration command, troubleshooting, and the exam preparations. Inside the principle, we go for the brief overview, a basic concept, working principle, and the basic network. First, let's look at the brief overview. Under the brief overview, in the MPLS VPN, when we talk about VPN, it means that it's a virtual private network. But this virtual private network is run based on the MPLS. When you run based on the MPLS, we should have three different type of components. We have a customer edge device, we call this as a CE, provider edge device, we call it a PE, and the core device in the provider's network. So the PE equipment is always facing to the customers, and CE is under the customer places, and the P routers is not connecting to anywhere, it's just connecting within their service provider network. So for the PE equipment, they're going to handling all the different type of customers, connecting to the different VPN site and connecting to the different customer. And from the traffic going through the PE will send through to another PE and reach up to the another different customers. So for the MPLS itself, MPLS is very important within the PE, P and the PE equipment. So this is why we need to using MPLS. So instead of using the IP, we are using a layer 2.5 MPLS layers to do the label switching from one PE to the P and P to the PE. So using the labels switching instead of using the normal IP. As we know that the MPLS is based on the layer 2.5 and they are based on labels. Based on MPLS, you need to know two things, the LSR and the LSP. The LSR is a label switch routers and the label switch path. So the LSR is based on who will be the router to do the label switching, and the LSP is the path, which path you are using. So based on these examples, for this PE going to the VPN 1, from VPN 1 to VPN 1, which path they need to be used? So they need to go into the P routers, from the P routers go into this PE routers. So in this one we call it as a label switch path, and this PE we call it as a LSR, and the LSR, the label switch routers. So they need to depend on the LSR to create up the LSP. And the LSP is also equivalent to your IGP best path. When you are not running as a TE, or your LSP is always equivalent to your IGP best path. So for the next, we look at what is the basic concept of the site. A single site is a group of the IP system with the IP connectivity which can be achieved independent of the ISP network. So within a site, I can have a different multiple VPN, just like over here. So we have VPN 1 and VPN 2 site. For this CE, we have only VPN 1 site, and this CE we have a VPN 2 site. It depend on your ISP how to distinguish which site you are belong to. So how they're going to differentiate which site you are belong to is all depend on your ISP. And have a look. Always when you have a VPN service, always we are worried about on the overlapping address space. So based on this situation, based on the diagram over here that show, under the VPN 1 site 10.0.0/24 and VPN 2 site 10.0.0/24 as well. So in this case, because of this right now, one is from VPN 1, the other one is from VPN 2. So they're not worried about they have a duplicate IP addresses because they are not covered under the same site. So you cannot have a duplicate address in the same site. But how they're going to distinguish that when I have two different VPN sites using the same IP addresses? So in MPLS VPN, they're using the VRF to distinguish a different customer. When I created the VRF, I created a VRF routing tables. So for this VRF routing tables, they're going to distinguish that this VRF is belong to VRF VPN 1 or VRF VPN 2. So they're going to base on your name to create an isolated routing table for every single customers, and they will not affect your public routing table as well within your ISP. So within this situation, VPN can use the overlapping space. So just now mentioned before, when you have on the different site, you can have the same address space. And the two VPN cover the same site, but the device in the site do not need to communicate with device using the overlapping address space in the VPN is also possible as well. So this is what I mentioned to you just now for the VRF. So but in Huawei we call it as a VPN Instance. So VRF is stand for VPN routing and the forwarding tables. So this is how they're going to distinguish. So and I have a CE under VPN 1, another CE is under the VPN 2. So I don't care which address space between VPN 1 and VPN 2 they are using, even though they are the same, I will not duplicate it or I will not affect it, even though they're connecting to the same PE equipment. Because when you have enabled the VRF, based on this situation, these ISP routers, they've created 3 routing table. They're creating a public routing tables and also VPN 1 routing tables and also VPN 2 routing tables. So in total, I will create 3 different routing tables when you created an instance 1 and the instance 2. So For you to create the VPN instance, you need to bind to the interface. After you bind it to the interface, they created all these extra VPN routing and forwarding tables to distinguish or to isolate a different customer space. So after the VPN instance, right now we are going to check on the RD and also the VPN IPv4 address. First, have a look for RD. RD is to distinguish the IPv4 prefix with the same address space and is run as a 64-bit. So just now we mentioned the VPN instance is also to prevent they have a same address space, but they are based on a different situation. Let me give you some examples over here to show you that what's the difference between the VPN instance and also the route distinguisher. So let's say right now they have a PE connecting to the CE1, connecting to the CE2. Within the customer premise over here, they have a segment of the 10.1.5.024, and under the CE2 I have a same segment as well. So for this PE, you connecting to the PE equipment and connecting to another PE, connect back to the customer as well. So just now we learned about the VPN instance. The VPN instance you define over here, we call it as a VRF. So this VRF is for the PE equipment to distinguish the route it received from CE1 and CE2. But when the route information when I exchange to P and the PE equipment on the other side, the VRF will not able to distinguish the same route because of the communication between the PE to the PE. We have to use a BGP protocol. When the route are going to import, when these two routes are import into the BGP, there are no difference. So in this case, we cannot use a IP-BGP. We have to use the MP-BGP protocol to carry a different customer route to the other end, to the other side. So for the MP-BGP, when they send the update, they are send the VPN v4 update. How they're going to distinguish? So first, that's why they need to have a RD. They're using RD plus your IP v4 update. So the RD over here is in total is a 64-bit. So let me give you an example. Let's say right now for the VRF1 and VRF2. For VRF number 1, I assign the route distinguisher as a 100:1, let's say, and the VRF2 is a 200:1. So how is the VPN v4 look like? The VPN v4 it will look like this. So the first update they're going to send it will be the 100:1 colons 10.1.5.0, and another VPN v4 update it will look like this: 200:1 10.1.5.0. So when this update sent from one PE to the other PE, there are difference. Based on the update, there are difference. They will not consider as the same route. And this is the only situation we need to use the route distinguisher. So VRF route distinguisher is always local significant on the PE equipment. So it doesn't matter for the PE on the other side use another route distinguisher or another VRF name. They are just identical on the same PE equipment only. There are no difference. So in this case, let's come back here. So this is a route distinguisher. So in this case, for the VPN-v4 address, always using the route distinguisher plus your IPv4 addresses. So IPv4 address is an IPv4 address with the 64-bit RD and transmit the VPN IPv4 address by the VPN IPv4 address family. That's why over here they're using the MP-BGP. They're using MP-BGP to carry over to the other PE equipment. Then the next one is a VPN target. The VPN target, we have an export target and the import target. So this target is very important to tell that which VPN site 1 or site 2, that can receive the route. I mentioned to you just now, we have a VRF RD and now is a VPN target. So the VPN target is for the PE to tell that whatever route that I export on the other side PE, I need to import. One export, one import. So in this case, I need to import 1:1 over here. So this is very important. Let's say you didn't define where your route export or where your route import wrongly. So different customer might receive a wrong route information. So this always have to be careful. So it'll be like this. Let's say right now, when this PE VPN1, I export 1.1, import 1.1. So it means that the PE below over here, I need to import 1:1 and export 1:1. So in this case, this CE and this CE, they can talk to each other. And from the VPN2, this PE equipment need to export and import 2:2 and 2:2. So in this case, the VPN2, they can talk to each other. So this target, they need to be matched. They need to be matched when export need to go to the import target, and import target is an export target. Alright, so they need to be matched. The next one is a MP-BGP. So MP-BGP use the address family to distinguish the different network layer protocol so as to correctly process the VPN IPv4 route. Just now we mentioned the VPN v4 route, they have to use the extended BGP, the MP-BGP, to carry the update from one PE to another PE. So this is a necessary. And the last one over here, so for the working principle, the information exchange between the CE and the PE. The information exchange between the CE and the PE. So first, the PE equipment, they need to learn the route from the CE side. So the route exchange between the CE and PE, they can run any routing protocol, even though a static route. So they can run as a BGP protocol, OSPF, ISIS, RIP, or a static route. They can run any protocol. Just the PE need to learn the route from the customer, and the PE equipment they're going to send to another PE using the MP-BGP. So regardless what type of protocol customer use, the PE have to exchange route from the customer side. Then the next one, after the PE learn the route from the customer side, this is how it looks like. So either I learn from BGP, OSPF, RIP version 2. So let's say this route is a 10.150.24. So PE1 will learn this update. After I learned the update, the PE1 I'm going to exchange the route to the PE2 using the MP-BGP. So under the MP-BGP, they will send the VPN v4 update. So you look at this 100:1:10.150. This is called the RD plus your v4 address. And the next hop is a PE1. SOO, source of origin, is a site 1, and the route target is a 100:1. This route target is a export route target. I export using 100:1. It means that the PE2 have to import 100:1. And the labels for the 10.150 is 15362. So this update, I will send it to PE2. When the PE2 receive, so it means that when the PE2 need to go back to the 10.150, I need to use the label of 15362, and the next hop is a PE1. So I need to point back to the PE1 to go back to the destination. So this is how the labels generated and how they are exchanged between the PE equipment. So PE2 will receive all this information, and for the PE2 sent to the CE2, I need to check what is the target that I define, the import target that I define, and send back to the CE2. Let's look at the next page. Alright, so in this case, you look at here. When the CE2 receives the route, is based on the PE2, the import route target. So the PE2 receive the VPN v4 update. They're going to remove or convert the VPN v4 update back to the IPv4 update. They're going to remove the RD and check what is the route target, and based on the route target, they know that which customer are going to send to. So after CE2 receive, it means that CE2 able to reach to this destination 10.1.5.024. And this is very important. This is for the MPLS LSP. So this is based on the basic MPLS LSP. Before we have an MPLS VPN, we must have a basic MPLS running under the ISP between the PE1, P, and PE2. They must have the reachability of their LSP. So how to reach to the PE2 and how PE2 reach to the PE1. So this is all the label is already generated. So this is on the LSP labels. So the label system that exchange the 15362 is a VPN labels. And this 1.1 is a LSP labels. So they have two different labels. So now let's have a look how the labels been switched between the PE, the P, and to the PE equipment. So let's say right now when the CE2 I want to go to the 10.1.5.1. So this destination address, this packet I will send to the PE2. PE2 first I will check 10.1.5.1. The PE2 know how to go, and I'm going to assign the 15362 labels. Okay, so 15362, you still remember for the 15362, where is the next hop? The next hop is pointing to the PE1. And the PE1 is equal to 1.1.1.1. So when the PE2 need to go to the PE1, I need to point to 1111. When 1.1.1.1, let me go back to the previous page. For 1111 is a label of 1024. When PE2 want to go to 1.1.1, my outgoing label is 1024. So I said that, okay, I add another labels of 1024. Then I pass this frame to the P routers. And the P routers receive, when the check is a 1024, let's look at the previous page. When 1024 coming in, I will swap the label to label of 3. I change to label of 3. As we know that label of 3 is a special labels. When the router look at the label of 3, it means they're going to pop the labels. After the label pop, I send to the PE1. So PE1 will not receive the outer label. They only will know that the 15362. When I know that it's 15362, I know this 15362 is come from the CE1. I will send it back to the CE1. So this is how the label switching within the MPLS VPN. So first, always we need to have, when we have a MPLS VPN service, so this is the things we need to be aware. First, we need to have an IGP in the ISP. Second, we need to have a basic MPLS to form the LSP. Number 3, we need to form the MP-BGP. Number 4, we need to create all the VRF, including a route distinguisher and the VPN target. Then we need to do the binding to we need to binding to into interface. After binding, the step number 6, we need to
Thanks for watching. Please do not forget to subscribe to our channel.